So guys, today we'll be discussing problem A, B, C, D, and E of Codechef Starters Division 2. So guys, let's start with the first problem, which is maximize sum. So what does maximize sum say, guys? First of all, how many of you all were not able to solve this problem, right? Okay, nobody? Or was everyone able to solve this problem? Great. So let me just discuss over this problem briefly. I hope I am audible and my screen is visible. Do confirm that in the chat. Okay. Okay. So if this is clear, you are given an array A of length n. You can perform the following operation any number of times. You can also do it zero number of times. The question says that you have to choose two distinct indices I and j and multiply both ai and aj by -1, right? That is, set ai to -ai and aj to -aj. Find the maximum possible sum of the array after performing this several times. So guys, what does the problem say? The problem says that you are given an array of length n, right? You have elements a1, a2, a3, a4 up to an, right? In one operation, what can you do? You can choose two indices I and j such that they are not equal, and you can set ai to -ai and you can set aj to -aj. Okay, this operation you can do any number of times, right? I want to know the maximum sum of the array which is possible after doing all these operations. Is this question clear, guys? Yes or no, guys? Tell me. Okay. So if this much is clear, I have a very simple question for you all. What is the most simple condition here, guys? Isn't the most simple condition that if all elements are positive or non-negative, in this case, we do not actually make any element negative because our goal is to make all elements positive, right? So in this particular case, the answer is just the sum of the array. Yes or no, guys? When all numbers are positive, you can just give the sum of the array. Yes? Yes or no, guys? Tell me. Put a yes in the chat if this is indeed clear. Yes? Okay. Now, guys, the question now is that we can have negative elements as well, and we need to solve it for negative elements. And using this operation, what is our goal, guys? This I, j, set ai to -ai, and set aj to -aj. What is our goal? Our goal is to make numbers positive, yes or no? We need to make as many numbers positive as possible. Yes or no, guys? Tell me. Yes. Now, if this is the case, let's say our array is something like this. I have 1, 2, 3, 4, and -5 and -2. In this array, you can see that there are two negative elements. So do you agree that since there are two elements, I can take one operation and make both of these positive? Yes or no? Tell me, guys. Yes? Okay. So now my question to you is, when there were two negative numbers, we could make all positive. Okay. Now tell me, if there are four negative numbers, can we make all positive? Exactly. Similarly, for 6 negative numbers, for 8 negative numbers, and so on and so forth. Basically, for any if there are even negative numbers in the array, we can make them all positive. So this is the first case, guys. When there are even number of negative elements in the array, we are able to make them into all positive. Right? Now, guys, the only change is that, let's say my array is something like this. Okay, so consider my this is 1, 2, 3, -3, -5, -7, and -6. We need to solve what is the case when there are odd negative numbers, right? Now, guys, when there are odd negative numbers, do you agree that I can take all other elements and make it into positive, and there will be one element left which is negative? Yes or no? Let's say this becomes +5, this becomes +7, and right now there is one element which is remaining, which is -6, which is negative. Yes or no? Tell me, guys. Yes. So, guys, since this is the negative element that is left, what can I do this? What can I do now? I can change this to positive, but I will have to change something else to negative because all other elements are positive. So which would be most optimal to change to negative, guys? Would it be 1? Would it be 2? Would it be 3? Would it be 5 or would it be 7? It would be 1, right? Or basically what I'm trying to say is, when there are odd number of negative elements, one element has to stay negative, and what is the most optimal case? It is the minimum element of the array, right? And minimum element of the array we would make negative, minimum by magnitude. Yes or no, guys? And then our array would become -1, 2, 3, 5, 7, and 6, and we can say that this has maximum sum. So is this idea clear to everyone, guys? Yes. So what is the basic solution? You count the number of negatives, right? If the number of negatives is even, okay, you can just print sum of array, right? And if number of negatives is odd, in this particular case, you can just print sum of array minus smallest by magnitude, minus smallest magnitude, right? What is smallest magnitude, guys? Like in the array, 1 is the smallest magnitude, right? Yeah, 2 into, correct. Because we are removing it from the sum of the elements, and also we are making it negative. Yes or no? Yes, there is a case when it is 0. So when it is 0, it is not considered. Yes or no, guys? And sum of the array, considering all are positive. Okay. Is this approach clear to everyone, guys? The idea is that we can make all numbers positive except one in odd case, and in even case, we can make all numbers positive. So if this much is clear, let me show you the code. The code is simple. I am having count, which stores the count of negative numbers. Sum stores the sum of the array. So I take in input of array. After taking input of array, I iterate through all elements. And after that, if I is smaller than 0, which means this, I'm iterating through all elements in the array. Okay, guys. So if this element is smaller than 0, it returns a 1, otherwise it returns a 0. It's kind of a ternary Boolean operation, right? Now, this count, do you agree, will store the count of negative elements in the array? Yes or no, guys? Now, one more thing to notice is that all elements can be positive. So I'm just making element is equal to absolute value of its element, because we noticed that all numbers can be positive except at most one element. So while iterating, I'm making everything positive. After that, I'm sorting it. The only thing that changes now is if the number of negative elements are odd, okay, if count modulo 2 is equal to 1, then I take the element with the smallest magnitude. Since I have made everything positive and I've sorted it, this element will have the smallest magnitude. So I just multiply it by -1 and then I take the sum of the array and print the sum. Is this clear to everyone, guys? If you have any doubts, feel free to ask. But if this is clear, we can move on to the next problem. Great. So if this much is clear for everyone, guys, let's move on to the next problem. What does the problem say? It is, one second, it is easy subarray sum. Rohit asks, what if ARR 0 is 0? It does not matter, right? It would still be negative. Like if you multiply 0 by -1, it would still be 0. It does not make a difference. Our solution still holds. Because for one number which was negative, I chose 0 and this number, switched it. So the number became positive and 0 remained as it is. Clear, Rohit? Okay. Easy subarray sum. You are given an array A of length n. You can perform the following operation on it any number of times. Choose an index I and change AI to 0. Your goal is to maximize the value of the maximum subarray of A. Find the minimum number of operations to achieve this. Note that an empty subarray has sum 0. Okay. So guys, what does the problem say? That we are given an array. Let me do this here. Again, the question says that we are given an array of length n, right? And here it can have negative numbers, it can have positive numbers. Let's say -1, 2, 0, 3, -1, 5, and -2. This is the array. On every move, we can select an index I and make AI is equal to 0. We need to find the minimum number of moves to make maximum subarray sum. Okay. So how many of y'all were not able to solve this problem, guys? Let me show you how you can come up with the intuition to solve this problem. Now, what does the question say? I need minimum moves to make maximum subarray sum. Do you guys agree that here, since I can make AI equal to 0, the value of AI after the operation only increases if AI is negative? Yes or no? I want to basically increase the value of the subarray, right? So I can only do that if the value increases after this operation. And AI is equal to 0 only increases the value of the array or subarray sum if AI was negative. So guys, first of all, let's have a look what happens when I make all negative numbers positive or 0. So you can see that this became 0, this remained 2, this is 0, this is 3, this is 0, this is 5, and this is 0. Okay. Do you see that the sum of this is nothing but 10? Yes or no, guys? This is the maximum subarray sum. You cannot have a subarray sum larger than this? Is this visible for everyone, guys? Like I can take this entire array as subarray and I will have sum 10. Okay. Now, guys, the thing to notice is that if you see the first positive is from here and the last positive element is here. And if you look at it, this is the actual subarray that matters, right? Even if there was a minus 99 here, the answer would still have been 10. Yes or no? Tell me, guys. Yes or no? Yes. So do you agree that instead of making all negative numbers positive, I can find my first positive number, I can find my last positive number, and I can make all elements between it which are negative into positive. So in this case, I only need to make this minus 1 into 0, and hence the number of operations is only 1, because if I make the array into minus 1, 2, 0, 3, 0, 5 and minus 2, my answer is still 10. Yes or no, guys? Tell me. If you have doubts, feel free to ask for doubts, guys. If you're not able to understand something, it is very important that you guys are able to understand. That's the goal of these post-contest discussions. Yes or no, guys? Clear?
Can use Adam's algorithm here.
What did you say?
Can we use Kadam's algorithm here to find the
Hmm?
maximum subarray sum? We
You don't
can
need
think in that log.
Cadane's algorithm, right? Like the only observation required is I will take the first positive and last positive, and all numbers between this I'll make 0, which are negative. Yes,
Okay, sir.
because if you look at it, my operation is to make AI is equal to 0, right?
Yes,
Now,
sir.
do you agree if I change a positive number into 0, it won't really increase my subarray sum because I'm reducing the sum of the entire array itself.
Yes, sir.
So the only operation I would do is making negatives into 0, right?
Yes, sir.
And hence, as I told, what happens when I make all negative numbers into 0? I get my maximum subarray sum. And now the minimum length of this subarray is just the distance between the first positive number and the last positive number. Is that clear?
Yes, sir. It's clear.
Great. So that is more or less the approach, guys. You can code this in O of n linear time. Let me show you the code for this since it was not in my contest. This is in my code, but I'll explain it to you. It's very clear. You take in the number of elements n. You have a vector of size n. After this, you take an input and you want to store the first positive number and the last positive number. Now, you just iterate. You have a for loop. You iterate through all elements. When you find the first positive number, you say start is I, and then you break. Otherwise, and after that, you want to also find the last positive number. So you iterate from 0 to n. When you find any number that is greater than 0, you can say that end is equal to I. What will happen is that the last index, since I'm going in order 0 to n minus 1, the last index where vi is greater than 0, this end will be updated. So is this clear for everyone? How using these two for loops, I will get my start and end range. Okay? Yes or no, guys? Tell me. Yes? Now, after this, if start is minus 1, that means that there are no positive numbers in the array. then you can print 0, because if there are no positive numbers in the array, there is nothing to do there. Okay, you can't, the answer is just 0. But apart from that, it is just the count of negative numbers in this range. So I have a count variable, and you just run a for loop from k is equal to start to k is equal to end. If any element in that range is smaller than 0, I do count plus plus, and in the end, I just print count. Is this clear for everyone, guys? Is this code clear? Is the approach clear? Do put a yes in the chat if it is indeed clear. If it's not, do let me know what I could explain more. And if it is clear, we could move on to the next problem. Clear. Okay. Just put clear, guys. If it is indeed clear, we'll move on to the next problem. Okay. So, guys, if this is also clear, let's move on to the next problem, which is Chef loves beautiful strings, easy version. This is the easy version of the problem. Here you only need to compute f of s for the given binary string. Okay. The beauty of a binary string t is defined as below. Let score is equal to 0. Repeat the following t minus 1 times. Choose an index I and delete ti from the string. Concatenate the remaining parts together. Note that this reduces the length of t by 1. Okay. After deletion, let k denote the number of indices such that for all indices, ti is not equal to ti plus 1. Now, once you find the number of such indices, you can add k to your score. Now, our task is given a binary string. I need to find f of s. Okay, guys? So what does the problem say? Let's have a look, right? The problem says that we are given a binary string, guys. Let's say this is my binary string. Okay. Now, on every operation, what do? I remove any particular index. Okay, let's say I removed this. Okay. After I remove this, I calculate the number of indices such that ti is not equal to ti plus 1. You can see that this is such an index because the adjacent elements are not the same. This is such an index because it's not equal to the next element. This is such an index, and this is such an index. So there are 4 such indices. So I add 4 to my answer. Now similarly, let's say now I remove this particular element. So after removing this element, you can see that I add 3 to my answer. Now I remove this particular element. You can see that I add 2 to my answer. I remove this particular element. You can see that I add 1 to my answer. And after removing this, I add 0 to my answer. So my final answer is just 4 plus 3 plus 2 plus 1, which is nothing but 10. Is the problem clear, guys? My problem is to find the maximum possible score. If this is the score for this operation, I want to find the max score. Okay. Ritik says, can you repeat? Okay. So if you look at this, right, 101010, okay, or let me take 1010 only. Now the length of this is 4. What do I have to do? I can select any element from the string and remove it, and then the number of the score that I add to my answer, or the score that my score increases by, is the number of indices such that number of indices I such that si is not equal to si plus 1. Okay, guys? Yes. Now, if I remove this index, the string becomes 101, and my answer gets increased by 2 because this is a valid index and this is a valid index. Now, let's say I remove this again, my string becomes 10. I add 1 to my answer. Let's say then I remove this, I add 0 to my answer. So my score, or f of this 1010, is 3 because the maximum possible answer here is 3. There are many possible operations you can do, but The maximum possible answer is 3. We need to find f of this string. Okay. Is this problem clear, guys? What do we need to find? Okay. Now, if the problem is clear, one thing to notice, guys, is that let's say all adjacent elements are different. The string is of this type. Okay. Do you agree that the number of positions, number of I, such that ti not equal to ti plus 1, ti plus 1 is more or less n minus 1 right now? Because this is valid, this is valid, this is valid, this is valid, and this is valid. Yes or no, guys? Tell me. Yes. Now, you can see that if I remove any character, then the number of valid numbers reduces by 1. Yes or no, guys? And now this gets added to my score. Okay. Let's say I removed this. So you can see that currently there are four valid indices. So 4 gets added to my score. Okay. Now, if I remove any character again, do you see that it becomes now again decreases by 1? It becomes n by 3, n minus 3. Yes or no, guys? If I remove this now, you can see that this is valid, this is valid, and this is valid. So my score increases by 3. Yes or no? Yes? Tell me, guys. Okay. Now let's say I remove it again. Do you see it? Now there are two such indices and my score increases by 2. Yes? And now if I remove another one, you can see my score increases by 1. I remove another one, my score increases by 0. Okay. So what is this, guys? This is 4 plus 3 plus 2 plus 1, which is nothing but 10. Now, guys, would someone like to tell me what is the formula for this? Let's say all elements are different, okay? And there are currently X valid indices. Do you see that here there are 1, 2, 3, 4, 5 valid indices, okay? But when I remove one, the valid indices become 4, okay? So now, if I have the number of valid indices, the answer is just x minus 1 into x minus 2 divided by 2. Yes or no, guys? Because the number of valid indices were 5 in the original array and I started counting by 4. Wait, this is not x minus 1, x minus 2. This is x into x minus 1. Sorry. Yes or no, guys? Yes. For example, the length of this was 6. Okay. 101010. The number of valid indices right now are 5. Okay. Do you see that when I remove my first number, the number of valid indices are 4. So it is 4 plus 3 plus 2 plus 1. Since x here is 5, so it is just n into n plus 1 by 2, which is nothing but 4 into 5 by 2, which is x minus 1 into x by 2. Is this formula clear for everyone? This is just, yes. Another formula that I want you all to notice, if the length is L, okay, if you consider 101010, then the answer again is L minus 1 into L minus 2 by 2. And let me show you all why. Tribhuvan says explain again. Definitely. Okay, Tribhuvan. So Tribhuvan, do you agree that currently the number of valid indices are 5? Yes or no, Tribhuvan? Tell me. Now, the length of this is currently 6. Okay. If I remove a particular index, do you agree the number of valid indices become 4? Yes or no? And I add 4 to my answer. Yes, Tribhuvan? Okay. So after I do this operation again, the number of valid indices become 3. So I add 3 to my answer. I do this once again. You can see that I will add 2 to my answer. Then I'll do this once again. I'll add 1 to my answer. Okay. Now the length is 6. Okay. But I want 4 plus 3 plus 2 plus 1. Okay. I wanted 4 into 5 by 2. But currently I have 6. So how can I get this formula? This is just L minus 2 into L minus 1 divided by 2. Yes or no? Where L is the length of the array right now. Okay. Is this clear? Okay. Now guys, the thing that we discussed is when all elements are different, adjacent elements are different. Okay. What happens when adjacent elements are same? Let's consider it is 1 0 1 0 1, and now I have a 1 here. Do you agree that the number of valid indices are 1 2 3 4? Yes or no? Now let's say if I added another 0 anywhere, let's say I added another 0 here, does it change the number of valid indices, guys? No, right? Exactly. Now the number of valid indices are not changing. So do you agree that if I remove this 0 right now, my answer would more or less still increase by 4 because I'm not removing my valid indices? Yes or no, guys? Similarly, let's say I remove this 0. Now, if I remove this 1, my answer would still increase by 4. Tell me, guys. Okay. So tell me that what I just count how many are not valid. Okay. Right now. And I subtract 1 from it because that 1 is basically the last element. And that last element does not count, right? Since I have two elements that I can spare and the number of valid elements, valid indices are 4, do you agree that my answer increases by 2 into 4 initially and then my string becomes 10101? Yes or no? Yes. And what is the answer for this, guys? The answer for this is nothing but L minus 2 into L minus 1 divided by 2. What is the length of this? The length of this is 5. So this is just 3 into 4 by 2, which is 6. Because for this string, wouldn't the answer be 3 plus 2 plus 1 plus 0? Yes or no, guys? Tell me. Are you getting my point, guys? Or is this not clear? Do tell me if it is not clear, guys. Okay. Harsh says it would be 4 plus 3 plus 2 plus 1. No, Harsh. When I have this particular string, I need to remove an element. Let's say I removed the element. Now I would only add 3, right? Yes or no? because these three are valid indices. So it would be 3 plus 2 plus 1 plus 0, not 4 plus 3 plus. So what is the basic formula we can see here, guys? I will just count the number of valid indices. Okay. What are the number of valid indices? Or I can just count this length, this L. Okay. So do you agree if I have this L, which is the length of this array? Let me show you how we can get the answer. Okay. 1 0 0 1 1 0 1, and let's add one more one and one more. Okay. Do you agree the length of the array, like if I remove the extras, the array is just 1 0 1 0 1? Yes or no, guys? Because this right here is an extra, this right here is an extra, and these two right here are extras. So the length of this is 5. Okay. Now tell me, guys, if I know 5, right? Can I know the number of extras if I know the length of the array? Are you able to come up with a formula for the number of extras? Tell me. What is it, guys? Isn't it just n minus 5, or basically 9 minus 5, which is 4? It is not valid, guys. In this string, this is not valid. So just keep that in mind. I'm not talking about valid elements. I'm talking about getting this particular string. Okay. Now, if I have this, okay, can you tell me that what is the initial score of this string? Like, if I don't remove anything right now, what is the score? This is a valid one. This is a valid one. This is a valid one. And this is a valid one. Isn't it 4? How is it 5, guys? It is 4, right? Yes. So do you agree that the score of this array currently is same as the score of this array, which is basically 5 minus 1, which is 4? Yes or no, guys? Yes? Okay. So since I have 4 extras, okay, you notice that I have 4 extras. Do you see that 4 times 4 would be added to my answer? Because when I remove an extra, my score does not change. Yes or no, guys? Yes. So my answer is nothing but extras, which is nothing but n minus L, okay, into length minus 1. Yes or no, guys? This is not the length of the original string. This is the length of this string that we got of alternating characters. Yes or no? After this, when once we get this string, we have removed all the extras. Now we have got this string. What is the score of this string, guys? Tell me. We just discussed the formula to come up with the score of this particular string. Would someone like to put it up in chat? Isn't it L minus 1 into L minus 2 by 2? Yes or no, guys? Tell me. Yes or no? Yes? Okay. Now, if this much is clear, guys, what is the number of extras? Isn't it again now just n minus L? Yes or no, guys? Tell. So eventually, if I'm able to come up with the length of this alternating array, my formula at the end of the day is just n minus L into L minus 1 plus L minus 2 into L minus 1, the whole multiplied by the whole divided by 2. The only thing I need to find right now is L. Yes or no, guys? Yes. So for an array, how do I find L? Do you guys see that these things can be converted to a single one? These things right here can be converted into a single zero. This can be converted into a one. These things can be converted into a zero. These things can be converted into a single one. And the length of my final or L right here is equal to 5. Yes or no, guys? Yes? Yes? So, how do I find L? I can just iterate over elements that are same and count how many times am I doing such iterations. This is the first time I'm doing this iteration. This is the second time. This is the third time. This is the fourth time. And this is the fifth time. Since I'm doing such iterations 5 times, L right here is 5. And then I can just apply this formula. Yes or no, guys? Okay. So that is more or less it for the problem. It is a linear solution. Let me show you guys the code for the same. It's kind of a two-pointers you could say, but not really. So I want to count the number of ways I can, I want to count L. Okay. So how do I count L, guys? Now, what I want to do is, let's do one thing. Let's keep count as 0 and let me keep here count plus plus. Okay, this will also work. Let me just submit this one. Okay, let me just run this and I will be sure 1015. Is that what is expected? Okay, then this will work. Okay.
Sir,
Yes, tell me.
sir, I have a doubt in the previous slide.
Yes, tell me.
So the previous slide.
Yes.
Sir, you have written 9 minus 5, 4. So 4 valid indexes, right?
No, no, 4 extras.
4 extras.
This is the formula for extras. Okay, like how many elements are there such that I can remove them and my k does not change. Like if you
Yes, sir.
consider if I remove this particular one, the number of valid indices did not change, right?
Yes, sir.
So that is basically n minus L, where L is the length of this string. Okay.
Yes, sir. And what about that L minus 1?
So if my length is L, what is the k of this string currently? It is 4, right?
Yes, sir.
So if length is 5, if L is 5, what is the k?
Sir, it would be 4, but if we remove 1, then we have the string 1010. Then we are considering that only 3 valid indices are there.
Yes, yes, yes. No, no. But initially we have this string. Okay.
Yes, sir.
Now we have some extras. And for each extra, if I remove it, you agree I'm adding 4 to my solution because the number of valid indices are this one, this one, this one, and this one, which is again 4, right?
Yes, sir.
So how many extras are there? N minus L. And for each of them, how much is my score increasing by? L minus 1. Yes or no?
Yes, sir.
And after removing all the extras, my string becomes something like this. Yes or no?
Yes, sir.
And for that, my answer is L minus 2 into L minus 1 by 2.
Okay, sir. I got
Okay?
it. Yes,
Great.
sir.
So if that much is clear, we could look at the implementation. Initially, my count is 0. This count is basically my L. Okay. Now, I have two this is just a 2-pointer solution. What am I trying to do? Initially, my I is at 0, my j is at 0, and I is smaller than n. I do count plus plus, stating that I got one block. Yes or no, guys? I'm starting at a particular block. For this, I am starting here, so I'm just doing count plus plus right now. Now, what do I do? While j is smaller than n and si is equal to sj, basically till I'm getting the same character again and again, I'm just doing j plus plus. Yes or no, guys? Tell me. Basically, I start here. You can see that this is 1. So I do count plus plus. Count is initially 1. Now, let me use a different slide. Let's consider this is the case. Okay. Initially, both my I is here and j is here. Now I'm moving my j pointer ahead. Okay, this is equal to I. I move it ahead. This is equal to I. So I move it ahead again. Right. Now, this is also equal to I move it ahead. So on and so forth till it reaches here. Do you all agree upon this, guys? Yes. Now, do you agree that now my job is to just move my I pointer here? Yes or no, guys? And then do this again and again. And every time I do this, I'm doing count plus plus, which is basically my L. So if this much is clear, that is more or less my 2-pointer solution. For I is equal to 0, j is equal to 0, I smaller than n, I plus plus. I don't have I plus plus here. I do count plus plus while j is smaller than n and si is equal to sj, j plus plus. Then I do I is equal to j. And in the end, I am just printing the answer that these value that we discussed. It is just n minus count into count minus 1 plus count minus 2 into count minus 1, the whole divided by 2. Don't forget to take everything as long or define int as long. This will help you to not get an integer overflow. It's an O of n solution. Is this clear for everyone, guys? Okay. Now, if this much is clear, let's move on to a very interesting problem, which is kill monsters. Now, guys, for kill monsters, the thing that we need to notice is that even though there are easy and hard version, only the constraints are different. So if you are able to solve the hard version, you will be able to solve the easy version as well. Is this clear for everyone, guys? Yes or no, guys? Tell me. Okay. So let's read the problem statement. This is the hard version of the problem, and we'll be solving it for the hard version also. Here the values of x and k can go up to 10 raised to 9, and hi can be as large as 10 raised to 18. It actually does not matter. You can just ignore the statement for now. In a video game, you are tasked with defeating monsters. The ith monster has a health value of hi. You start with an initial health value of x. You can defeat the ith monster if your current health x is strictly greater than health hi. That is, if x is greater than hi. After defeating the ith monster, your health changes to the value of that monster. Okay. Now you can do one operation at most once. What is that? You can multiply your current health by k, and you need to find the maximum number of monsters you can defeat using this technique. So guys, this problem is actually a very good lesson on some things. Okay, and I will share what. So what does the problem say? There are some monsters, okay, which is you have h1, h2, h3, so on and so forth, h4, h5, h6. Then you are given your initial health, which is x, and then you are given a k. In a move, what you can do, you can select any monster, okay, and if x is greater than that h of I, you say that you defeated that monster. So let's say you add 1 to your answer. After that, once you have defeated that monster, what do? You set x as hi. Now, during these operations, you are allowed to do one special move. Okay, exactly one. Okay, you are allowed to set x is equal to x into k. It can be in between any moves, and using this operation once, you have to find the maximum possible answer. Is this clear, guys? Let me take a example test case, which is 5321 uh, 53212345. Okay, so 53212345. In this particular case, this is x and this is k. If I just multiply both together, you can see that I get 6. Now, since I get 6, let me kill this monster first. My health becomes 5. Okay. After this, let me kill this monster. My health becomes 4. Let me kill this monster. My health becomes 3. Let me kill this monster. My health becomes 2. Let me kill this monster. My health becomes 1. You can see that I have defeated 5 monsters. So, and this is the maximum possible. This is just n. So the answer for this test case is 5 because I killed 5 monsters. Is this clear, guys? Is the problem statement clear? Okay. Now, guys, my question to you all is, let's say this move was not there. Okay, this x into k move was not there. What would happen, right? Let's say your health is initially 5 and the array is 1 1 1 3 2 1 2 5. Okay, and let's have 4. Do you agree that since the order of monsters does not matter, it is nowhere said that I want to kill the first monster first and second monster second, I am allowed to sort the array? Yes or no, guys? Why we need to sort, I'll tell you in a while, but do you see that we are allowed to sort the array? Yes? So guys, let me sort the array. Let's see what happens. It becomes 1 1 2 2 3 4 5. Okay. Now, what is the first large? Now, okay. Since there is no this xk operation, do you agree when I kill a particular monster, my health becomes equal to that health of the monster? So I want my health to be as large as possible always. So if I know which monsters I can kill all these monsters. Which one would I choose, guys? Tell me. The one with the maximum health, right? Because after killing this monster, my health remains the maximum. Yes or no? My health becomes 4, which is maximum among all. So I kill this monster and my health becomes 4. Okay. Now tell me, guys, my health is 4. Which monsters can I kill? I can kill all these monsters. Which one would I kill? Tell me. I would kill the one with health 3, right? Because my health is 4. I would, yes. So I would kill this monster. My health would become 3. Then I can kill all these monsters. I could kill either one of the two. It doesn't matter. Let's say I kill this particular monster. My health becomes 2. Then I am allowed to kill any of these two monsters. I kill this. Can you see that I was able to kill 4 monsters? Yes or no, guys? Yes or no? Okay. Now, guys, what is the observation here? The observation here is that if I come to know which is the largest element that I can kill for this particular X, it is 4, right? The answer is just the number of unique elements in this prefix. You can see that there are 4 unique elements in the prefix. So I can indeed kill 4 monsters. Is this clear, guys? Let's say K was not 5, but K was, let's say, 3. You can see that this is the largest index where I can kill when I can kill a monster. If I find the number of unique elements in this range, it is 2. And you can notice that I have to kill this and then I have to kill this, and the number of monsters I can kill is indeed 2. Yes or no? Tell me, guys. Okay. So for every prefix length, I can store the number of unique elements in that range, right? It would help. Now, guys, the thing to notice here is that we saw that, okay, if I sort the array, I would get something like 1, 1, 2, 2, 3, 4, 5. Let's say X is this. Now I need to find the largest index such that I can kill that monster, right? And this is this element right here. Now, before moving on to the next part of the problem, I'm just maintaining the number of unique elements in that range. So in this prefix, the number of unique elements is 1. In this prefix, it is 2. This is 1, sorry. This is 2. This is 2 again. This is 3. This is 4. And this is 5. This is the number of unique elements in the prefix. Yes or no, guys? Yes or no? Okay. Now, my task is to find the rightmost number such that it is smaller than X. Let's say X is 5. What is the rightmost number such that the number is smaller than 5? It is 4. Now, how can we find this number, guys? Tell me. There is a very standard technique. In a sorted array, you need to find a particular number. How do you do this? No, it wouldn't be lower. It could. Lower bound also works. But no, I would not like lower bound. Okay, exactly. We would use binary search. Okay. Now there are two options. Either you can do binary search. Yes, lower bound would work, Archit. Otherwise, what can you do? You can call the lower bound function. This is also binary search only. So more or less we are doing binary search. But the lower bound function, what does this do? If you give it a range, for now it is arr.begin and arr.end. arr.end. And let's say I give it x. It would give me that particular index iterator such that the value is greater than equal to x. So do you see my max index is just one index minus this lower bounds index? Yes or no, guys? If I do lower bound of 5, I get returned this index. I just go one index behind. Okay. So I can do this and then I can just print whatever the number of unique elements in the prefixes. Is this clear, guys, for everyone? Yes? Okay. Now, if this much is clear, let's introduce the problem. Okay. The problem is that I can multiply my current health by K. So what happens when I multiply by current health by K? So consider it is 1, 1, 2, okay, 2, 3, and 4, right? let's say currently my x is 4 and my k is 2. Do you agree that if I did not perform this operation, I would take this, I would kill this 3, then I would kill this 2, and then I would kill this one. Okay. Now, since I'm using this operation, the thing to notice is that, let me remove this one. Okay. Let me just remove this one. The thing to notice is that, let's say I killed a particular monster, right? Now, if I killed that particular monster, right? And I did the operation. Let's say in this particular case, my health is 3. Now, if I multiplied this by 2, you can say that I go back. And where do I go back? I go back to, again, I can lower bound and find this index. But after finding this index, I again do more or less the same thing. Let's say I killed 3. Okay. And then after killing 3, my health became 3. I multiplied it by 2, it became 6. Okay. I have killed 3. Just keep this in mind. Since my health is 6, now I would kill 4. Okay. After killing 4, my health becomes 4. Then I would go to kill 2 and then I would go to kill 1. So in this particular case, I can kill 4 elements. Yes or no, guys? Yes or no? Okay. Now, guys, the thing to do is, I want to do simulation. Okay. The basic idea of the solution is, I want to simulate. And what do I want to simulate? I want to simulate this exact thing. I'm currently on 3. Let's say I killed 3. After killing 3, I did my XK move. What is my answer? Then, okay, I killed 3. Let's say I did not do it. If I did not do it, it means that I killed 2. Okay. I killed 2. My health becomes 2. Let's say I did my 2 into K move. Now, what is my answer? Okay. Then, okay, I did not do the 2 into K move, so I can just go to 1. I killed 1, and now let's say I do my 2 into K and 2 into K move. What is my answer? Okay, guys, is this clear? Yes? No, I'm not like asking for the answer. I'm just asking if the idea is clear. I just want to simulate. Okay, if I was a real person that I'm playing this game, I would just simulate and see, right? If I did my move right now, what is the answer that I get? If I do, if I kill right now, what is the answer that I get? Let's say the answer that I get here is X. The answer that I get after doing this is Y. The answer that I get after doing this is Z. What is my final answer, guys? No, it is not always best, and I will show you why. If all these are my possible answers, what is my final answer, guys? Isn't it the maximum of all possible answers? Yes or no? Yes. So since it is possible of it is the maximum of all possible answers, I just need to I just need to find a way to do this efficiently. Okay? I just need to find all answers efficiently. Okay? Now, how can we do this? Let's have a look. Right? First of all, let's consider that it is again 1, 1, 2, 3, 4. Okay? Uh, let's keep it 3, 3 instead of this, right? I think this would more or less clear. Let's say X is currently 4. Then I come here, okay? I just do the lower bound thing and I get this particular index. Okay. Now, guys, let's say I kill this particular monster, my health becomes 3. Yes or no? And let's say K is 2. Okay, here. K is 2. Do you agree that after my health becomes 3, if I do my 3 into 2 option, then my health will become 6. Okay. And now that my health becomes 6, if I don't erase or do anything from my array, I still return here. Yes or no, guys? Since my health is 6, my lower bound is this, right? Now, how many unique elements are here, guys? The number of unique elements here are 3. Yes or no? Yes. Now, since I am pointing here, your question might be, can I kill a particular 3? And the answer is yes. Why can I kill a particular 3, guys? Because there are at least 2 instances of 3. That is why even though I came back to this particular index, because the frequency of 3s is greater than 1, I can still kill a 3, then I can kill a 2, and then I can kill a 1. But if this array was 1, 2, 3, and then I killed a 3, and then I would have come here back, since the number of unique elements in this range is 3, I would not be able to kill 3 because I have already killed 1 and I can't kill the same element. Do you get my point, guys? Yes or no, guys? Okay. Now, let me take a relatively larger array and let me show you an example through which it should clear it for everyone. Okay. Now, consider the array something like 1, 1, 1, 1, 2, 2, right? Consider the arrays 3, 4, 5, 6, 7, 8, right? Now, the number of unique elements is 1, 1, 1, 1, 1, 2, 2, 3, 4, 5, 6, 7, 8. Okay, because it's the same elements, it's same, right? The number of unique elements in the prefix is same. Now, let's say k is initially 3, right? Or let's say k is initially 5. Let's consider k is 5. Okay. If k is 5, after doing lower bound, which index do I get? I get this index. Yes or no, guys? And x is 5 and k is 2. Okay. Now, I start at 4, right? If I start at 4, let's say I kill 4. Do you agree that I have killed one element and my health has now become 4? Yes? Okay. Now, I killed 4. Let's say now I go to 3. I kill 3 as well. You can see that I have killed 2 elements. And now I get my health equal to 3. Okay. Now consider that I do my x into k move. So my health becomes 3 into 2, which is 6. Now, what is the index for this 6, guys? If I do my lower bound, what is the largest monster I can kill? It is this index. Yes or no? Okay. Now, you have seen that this is the range we killed. Okay. Now, in this range, can you tell me the number of elements that are occurring once or basically that are not present otherwise? Tell me, guys. in this particular range, which are the elements or how many elements are there such that if I remove them, they are not present in the array otherwise. Basically, the number of unique elements, or what I'm trying to say is how many elements are there such that their frequency is equal to 1. Tell me. There are two elements, right? There is 3 and there is 4 in this range. This range, guys. There are two, right? Yes or no? Two? Okay. Now, since I am here, there are 5 unique elements, right? Now, there are 5 unique elements. But which one can't I kill? Tell me, guys. Which elements I cannot kill? I cannot kill this 3 and I cannot kill this 4. Yes or no, guys? Okay. Since I cannot kill this 3 and I cannot kill this 4, do you agree that the number of elements that I kill if I start from 5 is just equal to 3? So how many total elements can I kill? I have already killed 2. So 3 plus 2, I can kill 5 monsters. Yes or no, guys? Tell me. Yes? Okay. Now, my question to y'all is, consider it was 1, 1, 1, 2, 2, 3, 3, and 4, 5, right? I killed 4. I killed this 5, this 3, okay? And my prefix elements are 1, 1, 1, 2, 2, 3, 3, 4, 5, okay? And after killing these two elements, I did my into 2 operation. So my health became 6. Do you agree that now I will go to this particular index again? Tell me, guys. Yes? Okay. So now I have 5 unique elements and I have killed 3 and I have killed 4. Now, how many can I kill, guys, if I start at 5? I can kill this 5, I can kill this 3, I can kill this 2, I can kill this 1. So do you agree I can kill 4 elements this time? Yes or no, guys? So I subtract 1. Okay. I have killed 2 and now I would be killing 4 if I start at 5. So the number of elements I can kill is 4 plus 2. That is 6. Yes or no? If I do this operation here. Now, what is this 1? Okay. This 1 is nothing but the number of elements in this range that occur only once in the array. Do you see that since 4 is the only element that occurs once in the array in this range, I would be subtracting 1. But if the array was 1, 1, 1, 2, 2, 3, 4, 5, and this was the range, you can see that there is 3 and there is 4 that occur only once in the array. So in that case, it would have been 5 minus 2 and not 5 minus 1. Is this clear, guys? Yes or no? Okay. So now, what if there are 3 threes? It does not matter, Archit. If there are, so the thing is that you go back only once, right? So I take one element once, and only if there is one more occurrence of it, I can take it. Otherwise, I cannot take it, right? Because I have already taken it. Yes or no? Ritik says, can you repeat this once? Definitely, Ritik. So, Ritik, consider that the array is, if, yes, yes, so on. So consider the arrays 3, 3, 4, and 5. And let's say your health initially is 5. Do you agree I will kill 4 once? Let's consider I killed 4 once and then I killed this 3 once. After doing 3 once, my health became 3. And after that, I did the into 2 operation. My health became 6. Since my health became 6, do you agree that the first monster that I will kill is this monster? Yes or no? Okay. Now, let's consider the number of unique elements in each prefix. So there is 1, 1 and 2, 3, right? Do you agree in this prefix there are three unique elements? Okay. Since there are 3 unique elements and I have already killed monsters in this range whichever I could. Now tell me which one can I not take? The first thing to notice is that I can take every unique element only once. I cannot kill 2 4s at a time, right? When I'm going in this direction, I cannot kill a 4 and then kill a 4. If I have killed a 4, then I have to kill something that is smaller than a 4, which is something like 3. So, how many elements can't I kill in this range? I can't kill this 4, okay? And this 4 contributed to this prefix unique elements. Why? Because this only occurs once, okay? If it was something like 3 3 4 4 5, I would have killed this 4, I would have killed this 3, okay? Now when I go back to this 5, I have another 4 to kill. But when it is occurring once, I cannot kill this 4. Yes or no, guys? Tell me. Yes? Is this clear now? Okay. If this much is clear, I just need to subtract the elements in this range that occur only once. And here I would subtract -1. So I can kill 2 elements in this range, which is this 5 and this 3. And how many elements have I already killed? I have killed this 3 and this 4. So I can kill all elements, which is 4. So the answer for if X is initially 5, K is 2, and this is the array, then my answer would be 4. Is this clear, guys? Yes? Okay. Now, last but not the least, I have to figure out a way to get this particular value. The one thing that I can subtract, yes? Now, how do I do this? Let me show you very simply in a range how you can find the elements that occur exactly once. Okay. Consider this is only my array 3, 3, 4, 5. Right. Now, which elements are occurring once, guys? This element is occurring once and this element is occurring once. Yes or no? Tell me. Okay. So in my array, let me put a 1 here and let me put a 1 here. Okay. And let all other elements be 0. Wherever there are elements that occur once, okay. Let's say there is a 1 here also, right? So here also there would be a 1. Let there be a 1 here and in all other places, let there be a 0. Is this clear, guys? Now, if I want to find the number of unique elements in a range, do you agree? Let's say I wanted to find in this range. Do you agree it's just the sum of elements in this range? The number of elements that occur exactly once in this range is 1. So how can I find this? Since I have put ones here, do you agree it's just the sum of elements in this range? Yes or no, guys? Tell me. Yes, and you just, if you can understand this, I hope this is clear with everyone, that whichever elements occur exactly once, below them I have put a 1, and in all the other places I put a 0. Now, in a range, if I want to find, in this range, if I want to find the number of elements that occur exactly once, okay, in the entire array, not restricted to this, you can see that this element occurs exactly once in the array. So how did I get this? I just want to know the sum of a range. Now, how do I do this? I can just do difference array technique, or basically prefix sum. Okay. If I take prefix sum of this array, it would become 1, 1, 1, 2, and 3. Okay. Let me do this again. If I take the prefix sum, it is 1, 1, 1, 2, 3. Okay. And the sum of this range is nothing but prefix of, okay, the sum of this range is nothing but prefix of r minus prefix of l minus 1. Okay. So what is the sum of this range, guys? Prefix of r, which is 2, minus prefix of 1, which is 2 minus 1, which is equal to 1. Hence, in this particular range, there is exactly one element that occurs once in the total array. Is this clear, guys? Tell me. Okay. Is this clear for everyone? Okay. If this is indeed clear for everyone, let me show you. If the approach is clear, okay, let me show you how we went about coding this. And before all of this, let me ask you one thing. Do you agree that one possibility is that before killing any element, okay, I do my k is equal to x move? Yes or no? One possibility is that before killing anything only I do my k is equal to x move. So after I do that, I will just come somewhere here and I just need to find the answer. And what is the answer then? It is just the number of unique elements in that particular range. Yes or no, guys? Yes? Okay. Now moving on to the implementation of this problem. Okay. So guys, I have my n, x, and k. Keep in mind that I have defined int as long here because it might overflow. Right? Let me take you through the code one by one. So I have nxk. I have taken in nxk. Now I am storing the only one or the prefix sum of the difference array technique that I'm using in the only one array. Unique, for every index stores how many unique elements are there in that prefix, and this is just my array. Now I take in my array, I sort it, then I use a map. Using the map, what do? I do m of ai plus plus, and then unique of I is just m dot size. M dot size returns the number of unique keys in the array. So at the end, I will have my prefix. I will have my unique array, which for every index stores the amount of unique elements in that prefix. Is this clear for everyone, guys? Yes or no? Yes? Okay. Now that this is clear, I want to make my only one array. And how do I do this? I iterate from 1 to n, 0 to n, and if frequency of ai is 1, then I say that only one I is 1, otherwise only one I is 0, because initially all elements are 0. After that, I am just taking its prefix sum. Instead of this, you can also do this. If I, only one I plus equal to only one I minus 1. Okay, this is what we are doing. Now, guys, after all of this is done, I want to find the indexes, right? And we just discussed, if I'm given the health x, which index do I start by? How do I know? I just do lower bound and I subtract a dot begin. I will get the index on which I can start. And do you agree that if I go one step behind, I will get the index from which I can start killing, and I will go leftwards? Yes or no, guys? Put a yes in the chat if it is clear. Yes? Okay. Now, similarly, uh, this is for the first index, and this is the second case. What is the second case, guys? I already do my x into k move. Okay. And after I have already done my x into k move, I start killing. Okay. So after that, I store my answer in my answer variable, and count is something I'll let you guys know soon. Now, if second index not equal to -1, it means that I can start at a particular index after doing the x into k move. So I initialize my answer variable to unique of second index, because I can start killing every element in that range and I have not killed anything yet. Is code till here clear, guys? Tell me. Yes or no? Okay. So I started at Okay. So if this much is clear, I start with my first approach. I have started at index is equal to index and I would be going leftwards. Just ignore this for now. I will be showing you all what to do. I start at I is equal to index and I go greater than equal to 0. I do minus minus. Since x is greater than ai, do you agree I can kill this particular array element right now? Yes or no, guys? If I can kill this array element, the number of monsters I have killed right now increases by 1, and my answer is nothing but max of answer comma I have killed count number of elements. If I do my x into k operation right now, how many monsters I can kill I am having here, I will let you know what this is. And then I just set my x to ai. So do you agree that maximum the if over all indices my answer is count plus solve of I over all I, whatever is the maximum answer is my final answer? Yes or no? Tell me, guys. Yes? Okay. Now the only thing I have to do is I have to solve for I. Now what does solve for I mean, guys? Solve for I means that from this index, okay, don't confuse it with this index. This is where I started. So do you agree from this index to this index, I have killed all? Yes or no? Killed all unique ones? Yes or no? Tell me, guys. Yes? Okay. So I need to subtract the elements in this range that occur exactly once. Yes or no, guys? Tell me. Yes or no? Okay. So what is the number of ones in this range, guys? Do you agree it's just prefix of index minus uh prefix of index minus 1? These two are different variables. Keep that in mind. Okay. Is this much clear? Okay. And apart from this, if I start at in dx, okay, this is my value. Do you agree? After killing the monster, my health would become a of index, because that is my final health, into k. Yes or no, guys? Okay. So if this is my particular health, how can I find my index where I would start? This is nothing but lower bound of that val minus a dot begin minus 1. Yes or no? Yes. Now, if this much is clear, if idx is -1, then I would return 0. Otherwise, I would find the number of unique elements in that in the prefix, which is unique of idx, and I would just subtract this value from it, which is nothing but here. This is just some edge case handling, that this range might not be completely within this particular range. For example, let's say it is 1, 1, 2, 3, 4, 5. Okay. I started killing at 4. So I killed 4, then I killed 3, then I killed 2, and then I killed 1. Okay. let's say I killed everything in this range. My health becomes 1. And since my health becomes 1, and I do my, let's say, into 2 operation right now, I go back at this index now. So do you agree I need to subtract the number of elements not in this much range, but actually in only this range? So that is why I'm having this as minimum of index comma idx. And if index, then only this just prefix sum. Index -1, otherwise 0. And yeah, that is more or less it. It's like an O of n log n solution. This is the only thing that matters. Okay. What matters is if x is greater than ei, then count plus plus answer is equal to max answer comma count plus solve I, and finally you print answer. And in my solve function, I am just telling, okay, this is my current health. After that, which is the index which I'm now going to start at? It is going to be this index. How do I do this? Using lower bound or binary search or anything like this. Is just binary search. And if index is -1, then I return 0. Otherwise, the number of unique elements in a range minus the elements in the range that I killed that have exactly 1 occurrence. Okay. That is more or less it for this implementation. Is this clear for you all guys? Tell me. Ritik says, can you explain line 44? So, second index not equal to -1, answer is equal to unique index. So, what does this mean, Ritik? Do you agree that it is also possible that before doing any operations, I do my into k operation and then start killing the monsters? Yes or no? Yes. So, in this particular case, what would I do? I have not killed any monsters yet. So the answer is just unique of the index where I start, right? So that is what I'm exactly finding. If I already do my x into k operation before killing anything, what is the number of monsters I can kill? That is just unique second index. Okay. Is this solution clear, guys? Tell me. I know it is not easy. This is a relatively hard problem. But this shows you how sometimes we can just simulate the problem and find a neat way to simulate this. Okay. This is just a very clean way to simulate this. I'm sure there must be many more solutions which are not that readable, but this is a very simple to code solution. You just needed to think what happens when there is no such operation of the second type, and if there is of the second type, how can you simulate this efficiently? Okay, guys? Yes or no? Okay. So if this much is clear, these are the first 5 problems of today's division 2. If you are able to solve this, you might have very well gotten a 2-digit rank or 100 something rank. So keep solving, guys. Don't lose hope. Keep practicing. And thanks a lot for watching. See you guys in the next contest. Till then, bye bye. Take care.